Hello, hello, hello. Okay. So write down. We'll discuss DPP also. Okay. So yesterday we discussed about energy conservation, right? K initial plus U initial is equal to K final plus U final. So today we will do that mutual gravitation also we have done. Two particles are attracting each other. That also we have finished. Center of mass, around center of mass, stars are revolving. Okay, binary star, correct? We have finished. Revise, okay? Very thoroughly you do. All topics are very important. Okay, anything can be asked. Thoroughly, slowly you work every day. Okay, don't think like this is important, that is not important. Don't think like that. Whatever I am teaching, you think like it is important. Okay, it is already filtered. Okay, I am not teaching unnecessary things. So, okay, fine. So today you write down satellite. We will start. Actually, I wanted to start yesterday, but no problem. I am starting now. Satellite, note down. Note down. They perform. They perform uniform circular motion around planet. Uniform circular motion around planet. Okay. So let's finish this topic first. Then I will discuss escape speed also. Okay. Escape speed is very easy. We can cover later also, but let's finish this. Very important it is. I wanted to start yesterday. No problem. Note down. Satellite. They perform uniform circular motion. What is uniform circular motion? Speed constant. Very good. Speed constant. Around planet. Around planet means center of planet. Around center of planet. So let's see how the satellite work. So planet is round objects. Planet is spherical objects, correct? So this is the center of planet. Now suppose I have some object. I want to throw some object, like any object. If I throw any object, if I throw like this, I'm holding that object and throw like this. It will fall back on earth. If we throw, if we throw any object horizontally, if we throw any object horizontally, then it will come back to ground. Then it will come back to ground. Any object you throw, you take any ball, okay, you throw like this, maybe like this you are throwing, or horizontally you're throwing, it will hit the ground. So imagine one person is standing on the surface of earth. This person will throw this ball like this, it will throw. So if speed is less, if speed is less, so the ball will fall here. If speed is more speed, the ball will fall maybe here. Now you are seeing the curvature of earth. If speed is more, the ball will follow like this. It is trying to fall on earth. Are you getting? The ball is trying to fall on earth, but earth is curved. Are you getting? Earth is curved, so it will never hit Earth. It will never hit Earth because the Earth is not very big. Earth also has limit. Okay, radius of Earth is not infinite. What is the radius of Earth? 6,400 kilometer. If you see Indian map, so the topmost point of Indian map, bottommost point of Indian map, the distance is around 4,000 kilometer. Okay, so the center to surface it is 6,400 kilometer. So Earth is very big, but not infinite. Earth also has some limit. So this is how the satellite perform circular motion. You throw, you throw object with enough speed, very high speed. It is not easy. Okay, lot of energy is needed to throw like this. So, like a small kid, if you give ball to small kid, maybe it will throw up to here. Correct. Some athlete, Olympic athlete, if you give ball, maybe up to that tree, that ball will go. Okay. If you use a gun, very powerful gun, the bullet will be fired. Okay, very high speed bullet will maybe up to that more distance it will cover. Okay. So the thing is, it will fall back to earth, but such that the speed is such that it will never fall. It will never fall on earth. So what this object is doing now? Circular motion. Okay. So this is known as satellite. This is known as satellite. So what happens? Some satellites are at some height, some satellites are at more height. So what is the role of rocket? You know, all the satellites are launched using rocket. So the rocket will lift off and it will go to very large height, maybe up to here. The rocket will go and very high speed it is. Then rocket will turn like this, means tangential. Suppose this is the center of earth. Now rocket will be perpendicular to radius. Then it will throw that satellite here. Okay. So velocity of satellite is like this, such that it will perform circular motion around earth. Okay. Then remaining part of the rocket will fall back on earth. Okay. Satellite will perform circular motion. Rocket will take the satellite up to some height. It will throw the satellite in the orbit, giving speed v. The satellite will start performing circular motion. The remaining rocket parts like boosters are there, boosters which burn the fuel. So boosters will fall back on earth. Okay, clear? So basically satellites are performing circular motion. So that is known as orbit. What is orbit? Path followed. Circular path followed. The shape of orbit is circular. Okay, path followed. Not down. Orbit means path followed. It is circular. They have radius. They have radius. Tell me, what is the radius of orbit? It will be more than radius of Earth. So radius of orbit can be written as radius of Earth plus height of orbit. Like you heard about International Space Station. What is the height of International Space Station? 400 kilometer. Height of International Space Station 400 kilometer. Okay. So what is the distance from center of Earth? 6,400 kilometer plus 400 kilometer. So what is the distance from center? 6,800 kilometer. Okay. So it is one of the biggest satellite. Okay. It is revolving around Earth. So orbit, you understand orbit. Orbit means circular path. So orbital radius means radius of orbit. What is the formula for orbital radius? Radius of Earth plus height. Okay, easy. Okay. Then speed is v. Speed is v. So what is the formula for time period? What is the time? Tell me. 2 pi r by v. Very good. R is the orbital radius. Then we can also say omega. Omega is 2 pi by t. This is the angular speed. So what is the orbital speed? Now we are deriving. Okay, note down. Next topic you write down. Orbital speed of satellite. Orbital speed of satellite. So now one small derivation is there, important derivation. See, suppose this is Earth. So and this is satellite. Radius of orbit of satellite is r. Okay. Now this satellite is performing circular motion. So what are the forces acting? Tell me forces. Gravitational force. What gravitational force? Mass of satellite small m, mass of Earth capital M. So tell me what is the force? Tell me force. Gravitation. Newton's law of gravitation. Tell me. G m1 m2 by r square. Very good. So this is the gravitational force acting. So and it is performing circular motion. So note down gravitational force provides centripetal force. We know that if any particle is performing circular motion, uniform circular motion, so there must be some force acting towards center. When satellite is here, force will be this way. When satellite is here, force will be this way towards center. When satellite is here, force will be this way. When satellite is here, force is towards center. Okay. So that force is known as centripetal force. It is a general name. It's a general name. So gravitational force provides centripetal force. What is the formula for centripetal force? Very good. And what is the gravitational force? G mm by r square. Correct. Very easy. Centripetal force is gravitational force. Now m r cancel. Small m means satellite. Capital M means Earth. Capital M Earth. Small m satellite. So what is v square? G m by r. So what is v? Square root g m by r. This is the formula. Note down. Okay. Orbital speed. Orbital speed of satellite. So if radius of orbit is r, the speed of satellite, speed, this is the speed, it is going like this, is this. Okay. G you know, capital G you know, capital M mass of Earth, capital M is mass of Earth. Now what is the value of small g? Tell me. What is the value of small g? G capital M by r square. What is this capital R? What is this? Radius of Earth. Very good. So G capital M can be written as, tell me, gr square. So put this here. What you get? Tell me. G capital R square by small r. Both formula you remember. This is in terms of capital G. This is in terms of small g. And r you can write capital H, capital R plus H. Capital R plus H. In the diagram also you mentioned. So this is radius of Earth, capital R, and this is height. What is the distance of satellite from surface? Height. Okay. Okay. Very clear. Okay. This formula. What is radius of orbit, radius of Earth, height, Radius of Earth plus height is equal to radius of orbit. Okay, fine. Now write one question. Note down. Two satellites. Two satellites at height r by 2 and 2r. Two satellites at height r by 2 and 2r. Find ratio of their orbital speeds. Find ratio of their orbital speeds. Okay, solve. So formula for orbital speed v is equal to square root of capital G capital M by r, and r is equal to r plus h. So this is square root of G capital M by r plus h. Okay, note down. So what is the formula? Okay, very easy formula. Square root of G M by r. Write in your formula diary also. Orbital speed. So two satellites, first satellite height is r by 2, second satellite height is 2r. Any answer? So capital G capital M will be same. So orbital speed is inversely proportional to root r. Use this. So V1 by V2, V1 by V2 is equal to square root. V is inversely proportional to 1 by root r. See, this is same. Correct. Tell me R2 by R1. Now what is R2? Tell me R2. R plus H2. R1 will be R plus H1. So R plus H2. What is the height? 2R. Then R plus H1. R by 2. Now you solve this. Okay, this is easy question. Okay, don't think it difficult. Easy formula, direct formula. Okay, 3R by 2. Correct? Tell me what is the answer? Root 2. 3R cancel. This 2 will go numerator. Root 2, right? Root 2 is to 1. Note down. Root 2 is to 1. Note down. Ratio of their orbital speeds. Root 2 is to 1. Okay, clear? Any doubt? Okay, done? Okay, fine. Now next you write down time period. Time period of satellite. Time period of satellite. So time period, you know the formula 2 pi r by v. Now substitute 2 pi r by v. V is square root gm by r. This r will go to the numerator. So 2 pi r square root r by gm. Now take this r inside. Inside root it will become r square. So r square into r will become r cube. This is the formula for time period of satellite. Note down. 2 pi square root. Note down. 2 pi square root r cube by g. Okay, clear? Very easy. 2 pi r by v. Distance by speed. Time is distance by speed. It is very easy formula. Basic formula. Time is distance by speed. It is circular motion. So 1 round means 2 pi r. So time for 1 round. Time for 1 round is time period. Time period means time for 1 round. Like clock. Clock also second hand. Second hand, what is the time period of second hand? 1 minute. Hour hand. Hour hand. 12 hours. Minute hand. Minute hand, what is the time period? 1 hour. Okay. Earth rotation, what is the time period? 24 hours. Earth rotation 24 hours. Moon. Moon also has time period 27 days. Every 27 or 28. Okay, 28 days. Moon completes one round. Okay, fine. So satellite also has time period. Okay. Okay. Now let's do some questions. Numerical. Let's do. So time period formula. Okay, and small r will be r plus h. Okay, this is clear. Okay. Next you write down. I am giving numerical now. Height is equal to h. Find orbital speed and time period. Solve this question. Next, height is equal to 0. Let's try to find the numerical value. Okay, find orbital speed and time period. So for orbital speed, use the formula for orbital speed square root of gm by r. Gm, we don't know the value of m. It is mass of earth, generally we don't know. It is given in question. But small g you know. So you write this gr square by r plus h. Use this formula. So orbital, when height is r, what is the orbital speed? Square root of g value you know 10. Use this formula. R square by height is also r. So r plus r. So this is 10 into r square by 2r. So this is 5r. Okay, 10 by 2, 5, r square by r cancel. Now this is 5. Now radius you know 6400 kilometer. Convert in meter. 6400 into 10 raised to 3. So 6400 into 10 raised to 3. So now you solve this. Approximate answer will get 64 into 5. So this is 232. 320 into 100 into 10 power 3. So 10 power 3, 10 power 2, 10. So what is the 10 power? Tell me. 10 power. 10 power 6. Then square root of 32. 32 means 16 into 2. So what is square root of 32? Tell me. 4 root 2. Very good. So 4 root 2 means root 2. Approximate value 1.4. 4 into 1.4. 5.6. Very good. 5.6. So root 32 is 5.6. So 5.6. Then 10 raised to 6. What is the square root of 10 raised to 6? Correct. So this is 5.6 into 10 raised to 3 meter per second. Now 10 raised to 3 meter, again you write 1 kilometer. So this is 5.6 kilometer per second. 5.6 kilometer per second. Okay, note down. 5.6 kilometer per second. Okay, understood? See, chance is less that this type of question will come, like exact answer, find exact answer. Okay, but suppose they ask, you can solve like this. Okay, so 5.6 kilometer per second. So that is the orbital speed of satellite whose height is equal to radius of earth. So this speed is very less or very large speed. Fast. It is slow or fast? It is very fast speed. Okay, this is very per second. 1 second, 5.6 kilometer. It is very fast speed. Okay. Okay. Now you solve the time period. How to find time? Now for time period you can use 2 pi r by v 2 pi you can take approximately 6, okay, 6 you can take, no problem. So 6 into r. So what is a small r? R plus h, so 2r, 2r, and v you got, this is v, 5.6 into 10 raised to 3. So you can solve 12 into 6400 into 10 raised to 3 by 5.6 into 10 raised to 3. Okay, 10 raised to 3, 10 raised to 3 cancel. You will get in seconds. You will get answer in seconds. So cancel by 4, 3 by 1.4 into 64 into 100. So seconds. Okay. Then again cancel. 1.4 I am taking approximately 1.5. Okay. So approximately this is 5 times, 0.5 times 0.5. It will become 1 by 2. 2 will go numerator. So 2 into 64 into, like this. See, approximate answer you can find. Okay. So 12800 second. In minute how much? How to convert this in minute? 12800 by 60 minute. Okay, like this. So this is approximately 213.3 minute. Okay, 213.3 minute. Okay, clear? So suppose this type of question comes like exact value, find exact value. You can solve approximately like this. Okay. Chance is very less chance they will ask exact answer, but still you practice this. Okay. Second question you do. What is orbital speed? Second question. Okay, solve. Try. Orbital speed. Use that formula. Small g formula. Small g formula. This one. Now height is 0. Height is 0. So what type of satellite is this? Height is 0. The satellite is going along the surface, correct? Satellite is going along surface. Satellite is moving along surface. So this is also known as grazing. This is known as grazing satellite. Grazing satellite. It is only theoretical. Actually, there is no satellite like this, but only theoretical satellite it is. Why we don't have any satellite like this? Because it will hit the buildings, it will hit the mountains, right? So not possible. But theoretically we can solve. So what is the formula? Use small g formula. This formula. Tell me. Tell me. G r square by r plus 0 square root of gr square by r. So square root of gr. Understood? Now substitute the values. What is a small g? 10. Capital R radius of Earth 6400 kilometer. Now kilometer into meter 10 power 3. So this is square root of 64. What is the total power of 10? 10 power 6. Nice. Now this is easy, very easy to find. So square root of 64, 8. Square root of 10 power 6, 10 power 3. Now unit, what is a unit? Meter per second. Now 10 power 3 meter means kilometer. So 8 kilometer per second. So what is the orbital speed of grazing satellite? Grazing satellite 8 kilometer per second. This is also very fast. Okay. So going along surface. So this speed is like this. Suppose this is Earth. This is Earth. and satellite is, here is the satellite. Satellite is going along surface like this. Satellite is going along surface. Okay, this is known as grazing satellite. Okay, this is grazing satellite. Okay, fine. So speed over time also you can calculate. So time will be equal to 2 pi r. Now radius of orbit is radius of Earth, and speed we got 8 into 10 raised to 3. You will get answer in seconds. 2 pi you can assume approximately 6. Actually 6.28. 2 pi is 6.28. Approximately I am taking 6. 64 by 8, then 100 second. Now this is in seconds. How to find in minute? 6 into 800 by 60. Okay, minute. 6 cancel, 0 cancel. So approximate how much time in minute? 80 minute. Okay, every 80 minute that satellite will complete one round. Okay, note down. Note down. Okay, so these are numericals. Numericals. Okay. Next, I will continue 840. Okay, so note down. So time period. Okay, clear. 2 pi r by v. V clear everyone. Square root of this formula you remember. Okay, very important formula. This formula. Square root of g capital R square by r plus h. Okay. Next you write down kinetic energy of satellite. Topic you write down kinetic energy of satellite. What is the formula for kinetic energy? Half mv square, and v you know square root of gm by r. Substitute here. So this is half small m mass of satellite. Now what is the square of this? Gm by r. So this is g capital M small m by 2r. Now capital G capital M can be written as a small g into r square. So this is g r square m by 2r. Correct? So these are the two formula. M G R square by 2r. Note down. mgr square by 2r. So this is the kinetic energy. Kinetic energy. Kinetic energy. Okay. Kinetic energy. Note down. Kinetic energy. Okay. Step by step we are going. What is orbital speed, time period, kinetic energy. Next. Now you tell what is the next energy? Potential energy. Very good. So potential energy. What is the symbol for potential energy? U. So what is the formula for potential energy? Minus G m1 m2 by r. This is the potential energy. Okay. So this can be written as minus G r square small m by small r, and small r can be written as r plus h. R plus h. So note down, this is potential energy. Potential energy. Next you write down total energy. Total mechanical energy of satellite. Total mechanical energy. Mechanical means kinetic energy plus potential energy. Actually energy is so many types of energies there. Thermal energy, wind energy, sound energy, okay, light energy, but mechanical only two, kinetic energy plus potential energy. Okay, what is the formula for kinetic energy? Satellite minus g mm by 2r. What is the formula for, sorry, plus kinetic energy is plus Gmm by 2r. What is the formula of potential energy? Minus Gmm by r. Minus Gmm by r. Now take common Gmm by r common 1 by 2 minus 1. 1 by 2 minus 1 is minus 1 by 2. So minus 1 by 2 Gmm by r. This is the total energy, note down. So total energy is positive or negative? Negative. Total energy is positive. Potential energy is positive or negative? Potential energy negative. Kinetic energy positive. Note down. Kinetic energy is positive. Potential energy is negative. Total energy is negative. Okay, remember these things. So, G m m by r. Suppose this quantity is k, or you can take bit any other symbol you can take. Suppose this quantity is x. Gmm by r is x. So, what is the formula for kinetic energy? X by 2. What is the formula for potential energy? Minus x. And what is the formula for total energy? Minus x by 2. Very good. Minus x by 2. Very good. So, now you tell me kinetic energy by total energy ratio. Kinetic energy by total energy ratio. This by this. X by 2 divided by minus x by 2. So, minus 1. Then now you tell potential energy by total energy. Minus x by minus x by 2. So, how much? 2. Correct. Good. So, kinetic energy by total energy is minus 1. Potential energy by total energy is 2. Okay, remember. Memorize this. You can also memorize like this. Kinetic energy is minus of total energy and potential energy is 2 times of total energy. Kinetic energy is minus of total energy, potential energy is 2 times of total energy. Okay, clear? Kinetic energy, okay, clear? Okay, fine. So, kinetic energy is minus of total energy, potential energy is 2 times of total energy. Note down. So, one ratio type of question you solve. Two satellites at height, two satellites at height 2r and 3r. Two satellites at height 2r and 3r. Find ratio of total energy. Find ratio of total energy. Height is given. Okay, height is given. So total energy. Solve. Use the formula of total energy. So I am writing all the formula once again. Kinetic energy G m by 2r. Potential energy minus G m by r. Total energy minus G m by 2r. So first satellite height is 2r. Second satellite height is 3r. So first you calculate what is r1. What is radius of first satellite? Radius of first satellite r plus h1 3r. Radius of second satellite r plus h2, so r plus h2 4r. Okay, so r plus 3r is 4r. Now use the formula. So total energy of satellite 1 by total energy of satellite 2 is equal to okay, mass is also needed, right? Mass. Okay, same mass. You take same mass. Two satellites of same mass. Two satellites of same mass. So that a small m is same. So E1 gmm by minus gmm by 2 into 3r divided by minus gmm by 2 into 4r. So what is the answer? Tell me. This is cancel. gmm by 2, gmm by 2 cancel. RR cancel. Tell me what is the answer? 1 by 3 by 1 by 4. So 4 by 3. Okay, 4 by 3. So you take care of mass also. Okay, if sometimes masses are different. If masses are different, then you have to consider mass also. Masses are same, mass cancel. So read the question carefully. Okay, height are different, mass can be same, can be different. Some satellites more mass. Okay. Okay, fine. We'll continue. Okay. Escape speed I will teach. So escape speed I will complete today. Escape speed, Kepler law also. Kepler law. Okay. Then this chapter is finished. Okay. This chapter is finished. Then today only I will start. I will continue up to 11:15. So calorimetry. Okay. Calorimetry we can start thermal expansion. Calorimetry will start. See, you have to do more practice. Okay. Every day you have to do more practice. I will try to finish both today. Okay, both. Then tomorrow, Friday, Saturday, Sunday. KTG, conduction, one day KTG, one day conduction, one day thermodynamics. Okay, you give at least 2 hour or 1.5 hour. You do you give every day separately, other than classes. Okay, practice for practice. Minimum 30 MCQ you solve. Okay, minimum 30 MCQ. Okay, I will try to finish this. Okay, clear? Understood? Then 11th class, what is left after this? 11th class, surface fluids. Okay, fluid surface tension. Then solids, elasticity. Correct. Then SHM waves. Correct. Waves oscillation. Correct. Oscillation waves. Okay, these things. We'll talk about this later. Okay, note down. So note down. Note down. I take break and continue.